The final objective in part 3 is called writing a series in summation notation. So all this is saying, if you notice that all these examples on your page, they have the sigma. The sigma means sum. What this skill is asking you to do, though, is to be able to recognize that this entire thing that I am about to square in blue, that entire thing is just another way to write out like a sequence of numbers. 1, 2, 3, 4. Technically this here and this here can be the same exact thing, just a different way to write it out, and it's used in different capacities. So it's an important skill to be able to go from one to the other. So in order to do this, I'm going to lay it out step by step again. And as I'm doing step by step, if you get hung up on a specific step, that's a good clue for you to just be able to say, I need help with just this step, and then I'd be able to be successful everywhere else. But as you're doing this work, I need you to write it out step by step, just like I do, so that it helps me see where you're at. So, all I need to know is I need to identify the lower limit. If I was going to do this and model how to do this for you, the lower limit, which in this case is 0. And then I need to identify the upper limit, which is, so 0 down here, upper limit is 4. So, what this is saying is, in the explicit formula, alright, you need to identify that as well, is 5m squared minus 1. So, what this is saying is they want to know the 0 term, the first term, the second term, the third term, the fourth term. Alright, from 0 to 4. That's all this is saying. So, please remember that 4 minus 0 is 4, plus 1 is 5. So we're actually looking for 5 terms. 4 minus 0 is 0, plus 1, is 4. Plus 1 is 5. So we're looking for 5 terms. Just keep that in mind. That's something to be well aware of. So then finally, my third step is to find each 0, 1, 2, 3, 4, 5. Base of 0 equals, and I input into my explicit formula, 5 times 0 squared minus 1. 0 squared is 0, 5 times 0 is 0, so the 0 term, and I want to end this with a nice pretty table, so I'm going to write that next. The 0 term is negative 1. The first term, 5, instead of m, I'm going to put 1 squared minus 1 equals, so 1 squared is 1, 5 times 1 is 5, 5 minus 1 is 4. So the first term is 4. The second term, 5 times 2 squared minus 1. 2 squared is 4, 5 times 4 is 20, 20 minus 1 is 19. And then the third term, 5 times 3 squared minus 1 equals, so 3 squared is 9, 5 times 9 is 45, minus 1 is 44. And then the fourth term, 5 parenthesis 4 squared minus 1 equals, 4 squared is 16, 5 times 16, oh, that might be out of my ability in my head. 5 times 16 is 80, minus 1 is 79. Now, notice, so I'm going to go and jump into example 2's room, but the sequence is then negative 1, comma, 4, comma, 19, comma, 44, and 79. This is my final answer. I need you to square that for your final answer, and even draw an arrow towards it. This down here, negative 1, 4, 19, 44, 79, and this up here are the same exact thing. One's just written in a sequence notation, and one's just written in sigma notation. Alright? And This is still a sequence. There isn't necessarily a arithmetic or geometric pattern, but it still is indeed a sequence. Go ahead and try the next two examples and raise your hand when you're done. I'll come check them.